Welcome to our video on the shaking table test of a timber building prototype. In this video, we'll explore about construction processes of a G+4 timber building prototype and how shake table test is performed. Let's dive in. Here is our timber building prototype, which is made of locally sourced, seasoned coniferous, C24, timber. A reduced scale, 1:8, prototype was physically tested on a shake table in order to improve the study's dependability. The study makes a substantial contribution to the field by highlighting the significance of connection types and design principles in timber building, particularly for applications in regions like Bhutan that are prone to earthquakes. The prototype has dimensions of 2,410 mm by 1,500 mm. The beam has a cross-sectional size of 40 mm by 60 mm, and the column has a size of 60 mm by 60 mm with a structure height of 1950 mm. For the slab, Phillips head screws were used, driven by a GBM 13RE machine. The spacing between the screws was determined based on working comfort, ensuring rigidity and secure connection with the beam below. To elaborate on the beam-column connection, timber-to-timber connections, specifically mortise and tenon joints along with nails, were utilized. For the cross-junction, a 2 cm by 2 cm mortise was drilled into the column. The inner square box, 2 cm by 2 cm, represents the solid remains left intact after the mortise is created, as demonstrated in the prototype model. Prototype set up on shake table test. 1. Connection of baseplate to shake table with the help of nuts and bolts. 2. Placement of prototype on the baseplate. 3. Anchorage of prototype to the baseplate with the help of L-gusset plate, 6" by 4" and nails. An electric servomotor type vibration tester is used for the shaking table to simulate and study the dynamic response of structures under various conditions. This type of vibration tester utilizes an electric servomotor to generate precise and controllable oscillatory motions. The servomotor's capability to provide high torque at low speeds, along with accurate positioning and speed control, makes it ideal for creating realistic seismic simulations. The model was then tested with a seismic ground motion of 0.2 G data earthquake which occurred in Thimphu on September 12, 2018 to perform an inspection and damage assessment of timber structure using shaking table.